So we start with Newton's first law, which we have already studied. It says a body at rest remains at rest, and a body in motion continues to be in a state of uniform motion unless and until it has been compelled by an external force to change a state of rest or of uniform motion. So as we discussed this first law, we got to know about something which is called a net force. So if you have a body, means if you take a body and you eliminate all forces, I mean take the resultant of everything, and you find that finally after doing all cancellations, opposite forces, this forces, I find that there is a net force. If there is a net force that is working on this body can never be in uniform motion. This is what is Newton's law. That means whenever a net force is working on a body, that means this body will not be in its uniform motion, will cease. Means there won't be any more uniform motion. So if there is no uniform motion, that means the velocity of this body is going to change. And if the velocity changes, it creates two velocities. One is initial velocity and final velocity. And obviously these will happen over a period of time, which means that a new quantity called acceleration will appear, which is equal to v minus u divided by t. Have you understood this? Now this law is also known as Galileo's law of inertia. Now we get to know a new term today, and first we'll debate on that term, what it is. So our new term for the day is inertia. Inertia. Inherent property of a body. It's a built-in property. Just like a child is born with a degree of stubbornness. A very obedient child has very less stubbornness. A disobedient child will have more stubbornness. So what is stubbornness? It means जो करने ना बोलो वही वो करेगा, है ना? Please don't watch the TV and go to sleep. You will watch the TV. And please get up from sleep. No, now I will sleep. So you try to oppose whatever is being asked to you. So every body has a built-in property called inertia. Now question arises that a body at rest remains at rest. Why did the body not go in motion? And a body in motion continues to be in uniform motion. Why is it continuing in uniform motion? Why is its uniform motion not ceasing? In both the cases, we have seen that to do that, that is, if a body is at rest, to make it move, I need a force. That means a body at rest will remain at rest. It's like some dheet, couch potato. If the body, if the body is at rest, close it, beta. If the body is at rest, push it, push it, push it. Yeah. If the body is at rest, the body remains at rest. It's like a couch potato. Question arises, why did the body not get into motion and show some fitness? And if the body is in motion, it continues to be in motion. Again, we say, why does it not come to rest? So in order to do both the things, you need an external force. Now, why are you needing that external force? It's like a couch potato is seated out here and he is not ready to move. So you need an external force to move him from a state of rest to motion. That means that force is doing nothing but is overpowering his internal stubbornness. Do you agree or not? So inertia is something like that. Every body possesses it. Every body possesses it. Okay. Inertia, let's understand, is an inherent property of a body. This is an inherent property. Means whether you apply any force or not, inertia is built in the body. It's like the amount of arrogance, not arrogance is not, stubbornness is the right thing, you are born with. सबके अंदर है थोड़ा सा. Can you go to Ratnadeep now? अभी नहीं. Later, I'll go later. Can you just switch off the fan? No, why only me? Everyone has that. So it's an inherent property of a body. Now what happens? Whenever we have a body, this body is at rest, okay? In order to bring this into motion, we have understood that we need what? We need a net force. This is understood by us. And similarly, if your body was in motion, rather uniform motion, and to bring it to rest, you again need some sort of a net force. Agreed. If you see both the cases, you are trying, and consider the body as a child, you are trying to counter his lazy factor, right? If he is watching TV, he keeps on watching TV. You are trying to make him stop that. So what are you overcoming? You are trying to overcome his stubbornness. So this net force in both the cases is trying to overcome the inertia of the body. Okay. Sometimes we say, get up early in the morning let's go for a walk, you will feel fresh. But when morning comes, not no day, tomorrow. Then common word we use, so much inertia she has in her life. Ask her anything to do, she will not do. So that net force is required to overcome the inertia. And inertia is inherent property of a body. Does a butterfly have inertia? Yes, everyone has an inertia. And inertia is also a measure of mass. It's a measure of mass. More you have inertia mass, it's measure means we won't measure mass, measure mass by inertia, but inertia is a measure of mass means the more you are bulky. Okay, 1 minute. Huh? It will come automatically. I mean, 1 minute. That happens. Just 1 minute. Huh? I'll help it. The camera just takes over. Give me a minute. Just going to red. Every time this nonsense will keep happening. Yeah, please. Yes, because it isn't. Now it should come. It's become green. Yeah, that's a changeover from battery to. No, not always. What happens? The camera has got a battery. I can run the camera without the power. But in that case, what happens? Sometimes the battery goes off, it will switch off. So once it charges off, say right now it is green. That means the camera is completely charged. But still it is plugged on. It's just like your mobile. Hey, hua, aja. 2 minutes. Yeah. So as I was saying, the net force is required to overcome the inertia. And we don't measure mass. Mass is a... Once again, it's... 1 minute. Huh? Mass is a measure of the inertia of a body. Okay. Mass is a measure, inherent property. It's a measure of mass. Rather, I would write it in a reverse order. It makes more sense. I would say mass is an indirect measure of inertia of a body. What do I mean by that? Okay. I have a small puppy of Labrador breed who is lying on the ground, and I just pat the puppy, get up. You expect that the puppy will get up. And you have a buffalo who is lying on the ground, and you pat the buffalo, get up. He will not get up. So more you have mass, the more mass you have, the more genda you are. You're like a rhino. You'll have more of inertia inbuilt into it. Are you understanding? So just let's see an example. A cycle or a bicycle of yours, the bicycle is stationary. You have to pull it, apply a net force to bring it into motion. But if it was a truck, do you think just by a pull the truck will come on? No. More is the mass, more is the inertia. Now, since we have understood it, let us try to define what is inertia, the thing which you are looking for. So it's said, inertia is an inherent property of a body by which it opposes any change in its state of rest or of uniform motion. Inertia is an inherent property of a body by which it opposes. It is going to oppose what? Any change in a state of rest. If I'm at rest, please don't ask me to walk. I'll be at rest. And if I'm in motion, please don't ask me to slow down or speed up. I will continue to be in uniform motion. ना रिपीट करूंगा क्योंकि आप डेफिनेशन लिखने के पीछे रहते हो ना, आप समझो ना चीज को. मैं see, it's very easy for me to just give you a definition and teach. That we will not learn. First, understand. I give so many couch potatoes and everything. So inertia is like the habit of stubbornness. So you try to define what is stubbornness. I mean, any day when it will think that it will disturb you, it will keep on disturbing you. So what do you mean by stubbornness? Stubbornness is an inherent property of an individual by which he tries to oppose anything that he has been asked to do. What is inertia? It's an inherent property of a body. It is directly related to the mass. The more you have mass, the more is the content of inertia in you. A lighter body will not show that much reluctance to the change in a state. State of what? Rest or motion. Inertia comes into play whenever you are trying to change a body state. I'm in rest. I love to be in rest. No matter you have to apply a net force. What is this net force going to do? It has to overcome my inertia. Why do we motivate a child? Get up, you will get more oxygen early morning, your lungs will breathe good. That is motivating you, so that the inertia which makes you again pull up the bed sheet and sleep, that inertia can be overcome. And whenever someone doesn't behave, then we say the body has a lot of inertia. Kuch nahi hoga iska, she or she has a lot of inertia. So how do we define it? Inertia is an inherent property of a body, right? Due to which it opposes any change in a state of rest or of uniform motion. State of rest or of not necessarily uniform motion or of motion. Uniform motion is a better word. Any change in a state of rest or of uniform motion. What did you define in Newton's first law? You defined that when a body is at rest, it remains at rest. Now the question arises, why does a body at rest remains at rest? Because of inertia. So in order to bring that body into motion, you have to apply a net force. By doing so, what do you overcome? You overcome the inertia of the body. A body in uniform motion continues to be in uniform motion. Why does it do so? It loves to do so. Once you want its uniform motion to be broken, you have to overcome its inertia. Now let's see some examples. So is the definition now correct? Likh lo chahe to. Inertia is an inherent property of a body due to which it opposes any change in a state of rest or of uniform motion. And what is that change? That's what is Newton's first law. A body in rest loves to be in rest. Usko mat chhero. Chheroge to wo, it will not immediately listen to you. Now you have to give him some sort of dose. That dose is the net force. Once you get net force, the inertia of the body is overcome. Understood? Further, you can also write that mass is an indirect measure of the inertia. More is the mass of a body, more will be the inertia exhibited by the body. That's common sense. Yes or no? If a stone is at rest, do you think it will be very easy to bring it into motion, a big boulder? No. But if a tennis ball is at rest, a gentle push by your leg will actually induce some motion. Right? Similarly, a truck is in uniform motion and a butterfly is in uniform motion. Whom do you think it is easy to change a state of uniform motion? Obviously, the butterfly, because the butterfly has less mass and less inertia. Okay, now let's see some of the very common examples that we see due to inertia. Okay, one of the very common things that we see due to inertia. Number one, right? Suppose this is you sitting in a bus, right? This is you sitting in a bus, and let's make the cart. Let's say this is the cart of a metro. Okay, this is the cart of a metro, and you're sitting out here, right? Now what happens? The body is at rest, so you are at rest. As soon as the metro starts, don't you feel that if you're holding it, we always say, always face the direction of the travel, right? As soon as the metro starts, you will just pull back. Why does this happen? Because your body is at rest, right? The entire body is at rest. What did the metro cart do? The metro cart started to move. As it started to move, the lower portion of my body has been compelled to move. But my body resists that change. So the upper portion of the body says, nahi move karega. You fall back. Similarly, you are on a metro or on a bus, and suddenly it is braking very steeply. So what happens? Our lower portion of the body is in motion, right? As soon as the bus stops or brakes, the bus has come to a halt. The lower portion has been, it's like your body was moving, suddenly your lower portion of the body has been held. So what does the upper portion of the body say? No, I'll still continue to be in motion. And that's the reason that you are always guarded with something which is known as a seat belt. Though the seat belt is a different concept, right? These are called ELR type seat belt. Just forgetting the complete definition: elastic, retracting, and then this is another word. A seat belt is so designed that if you bend forward to just scratch or itch your leg, it will allow you to come forward. But if there is a sudden impact, when there is a sudden impact, what happens? The body's bottom portion is brought to a halt, and the upper portion will immediately come and bang on the dashboard. So on a sudden elastic locking retracting, I think, elastomeric locking retracting. So it will not allow the body to come. Try to sit with your seat belt and gradually bend forward to itch your ankle, it will allow you. Try to sit with the seat belt on, ye sab dekho, and just with a shock you try to come forward, it will just lock you. Have you experienced that in a seat belt? No, that will not work. That pull works only in gradual. Okay, you didn't do another one. Try to lock your seat belt and just pull it with a pressure. Suddenly, it will not come. It will not come. That is the beauty of the seat belt. Seat belts work like wonders. Work like wonders. And the best example is the person standing in front of you right now. The thing that has happened in my life, it's only seat belt works wonders. The long backstory. Sometime I'll share you with photographs. Okay. And you know, in any car, anything that is unfastened is like a missile in the car when the car will collide with something. It can be even a mobile. It can be even a pen or a pencil is sufficient to kill you. Because when the car will have an impact, that body will just fly out and hit you anywhere. So if you have any things which are going on long drive, water bottle, anything, everything should be fastened and kept. And seat belt is very mandatory for the rear seat person also, because a rear seat person on a long journey generally tends to sleep, and you might just get into a pothole, or you might not see a rumble strip and you get on, you just go and hit on your bum. So whenever you are sleeping, fasten your belt. Belt saves life. It's a miracle device. Some people think seat airbags and all, those are all secondary. Belts save your life. And the seat belt works in what manner? ELR, usually elastic, locking, retracting. So what is an example of inertia? Suppose there are persons who are standing and they are holding the handrails. Immediately when the body starts, this person will be actually falling back. And if it is in motion and it breaks, the person will be falling on the front side. This is a very common example. I hope all of you must have experienced it. Number one. Means any day there is any sort of what you call, when we say that any change in the state of either rest or of uniform motion, body will object to that. Here the body was in uniform motion, you suddenly braked. So the bottom portion of the body has been stopped. The top portion opposes. Got it? Let's see one more example. Like this is also a very common example you can do at home. You can take a glass, and on this glass you can actually put what is known as a card, playing card. And on this playing card, put something like a heavy coin. Put a heavy coin, like a 5 rupee coin or a 10 rupee coin. Understood? Right? And try to hit this card, or try to just strike out the card like you strike the carom striker. The card will fly out, the coin will immediately fall into the glass. Why? Because the coin is heavy. It has more inertia. The card obeyed to your change in state. The card also has inertia, but the card obeyed to you. Hey, ciao, he went. The coin says, I have a lot of inertia. I will object to the change in my state of rest. So it stopped. Now see how Newton's first law is actually brought into use by many people who are not literate or educated. See how it happens. So this is a nice story. So there is a truck, and this truck is actually operated by two fellows. There will be a driver who will be operating the steering, and there will always be a helper along with it. Okay. This truck has got timber logs which are loaded on it, timber logs, and they are loaded in horizontal manner. My drawing is not correct. So if I try to show it from this view, then the timber logs will be seen like this. Are you understanding? Logs of timber. When the truck goes for a trip, the job of the driver is to take it to the destination, stop, and then this attendant who is there, his job is to unload all the timber. The drivers are very particular about their job. For them, this is an underrated job. They will never do it. So one fine day, this driver is going. That's true story. There's a video of it also. This attendant is not there. And you as the recipient, you will say, that's not my headache. I have paid you for carriage and delivery. You need to deliver all the timber. So thoda sa pada hua tha, Newton's first law. So what he opens that particular, the door which is there. He has just opened it. He takes the truck, and drives it at a very high speed, a full round, and comes to the yard where he is to offload it, and just brakes the car. everything falls in tuck, 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 tuck. He just Newton's first law. A body in motion wants to be in motion, but what this fellow did, he killed that motion by applying a net force, which was the braking force. So the body will now display inertia. Why did you kill my motion? I'm not going to stop. Let the truck stop. So all of them rolled one by one, and properly they got stacked up. Newton's first law, an example of inertia. Have you understood now? Is inertia clear? So if you see these discussions that we had in the last class and this class, all we got to understand from Newton's first law is that Newton's first law first time defines about force, that when a net force is applicable on a body, it's is no more in rest or no more in uniform motion. Acceleration is born, but we did not see any sort of any mathematical parameters so far. We just get to know an attribute of force, that a force is something which can change the state of motion or rest of a body. What you used to study in grade 8, a force is an external or an internal influence which can change the state of rest or motion, and that is absolutely clear now based on this, that if you apply force, the state of rest or motion can change. This is clear. Further, we got to understand that the force on whichever body it is applicable, that body has an inherent property called inertia, which it will display whenever this net force comes into. If the net force is sufficiently high that it can overcome the inertia, the net force can achieve its quest. Quest can be to bring the body from rest to motion, or to bring the body from motion to rest. Is this understood? And in order to change the state of rest or motion, inertia has to be defeated. If inertia is not overcome, you will not see any change in state or rest, no matter how much your net force is. That means your net force is not enough. So your net force should be enough to bring about that change. Is this clear? This is all about Newton's first law. Newton's laws are never proved, but nothing happens in this universe that actually you see which opposes. And when you go to higher classes, you will see Newton's laws from Newton's inertial frame of reference. In first class I told you there's a frame of reference. Like for example, okay, like the inertial frame of reference is very interesting. You are seated beside you, right? And I start running towards you. And then you see me from your side. What do you see? You see me approaching towards you. That is your inertial frame of reference. If you change the frame of reference to me and I run towards you, I feel you are coming closer to me. Yes or no? When you run, the destination appears coming closer to you. But ask the question, Jaideep sir, were you running? Yes, I was running. Ryan, were you running? No, I was not running. Then how come this is true? Jaideep feels Ryan is coming near to him, and Ryan feels I am coming nearer to him. That's because there are two different inertial frame of reference. He sees it from his frame of reference, but I am the moving body. And if I make myself fixed in my frame of reference, I see him as the moving body coming towards me. ऐसा बहुत कुछ concepts है जो आप आगे classes में पढ़ेंगे. So is Newton's first law clear? We now come to Newton's second law. Okay. Now Newton's second law will bring mathematics with it. Newton's second law. And there are many approaches to it. First, we will see what is the grade 9 kiddo approach. Newton's second law. Okay, what did the first law tell me about? The first law, in brief, tells me about a net force, and the net force is F. This net force can do two things. It can bring from rest to motion, or from uniform motion to rest, whatever it is. Newton's second law is going to quantify this net force. Okay, Advait, if you don't switch off your cameras, better don't kill my mood. You can sweetly disconnect from the class. I don't mind that. Okay, Newton's second law is the law which is going to help me. And I think I need to remind that every time. Newton's second law is going to quantify this net force. So we say, first understand the force. And when you say force, it's basically the net force. Which is this net force? The same net force that you spoke about in first law. Acting on a body. Okay. And let's say this force is F. Is directly proportional to the mass of the body. Force is directly proportional to the mass of the body. The force acting on a body is directly proportional to the mass of. Obviously, just try to think. If you want a net force which has to bring a body from rest to motion, and you have got a sweet little Labrador puppy and a big bull, who has more mass? The big bull. So if you have brought change in both the bodies, then the force on the Labrador is FL, the force on the bull is FB. Which force is more? FB is more. The force is directly proportional to the mass of a body, right? And then it further says that the force acting on a body is, that is F, is directly proportional to the acceleration produced in the body. Okay, to the acceleration produced in the body. Just think, I was going at a speed of 5 kilometers per hour. Suddenly somebody pushed me from behind and I now started to run at 7 kilometers per hour. He was going at 5 kilometers per hour, and let's say mass is constant in both our case. He started to run at 6 kilometers per hour. Whose acceleration is more? Obviously mine is more. For the same time, more change in speed was observed. Don't you think to induce that more acceleration, I must be, so I was subjected to more force? Yes. So the force acting is directly proportional to the acceleration of the body. Understood? Now, if I combine these two, this is typically grade 9 approach. If you combine this, it says force is directly proportional to mass and force is directly proportional to acceleration. Combining both, I can say force is directly proportional to the product of mass and acceleration. Many remember it, father directly proportional to ma. Force is directly proportional to mass and acceleration, right? Now, if you are talking in terms of SI unit, right? So if you go to grade 8, then how do you equate it? You will put some constant of proportionality. Don't you agree? Force is directly proportional to mass into acceleration. So force must be equal to some constant of proportionality, K. And if you are working in SI unit, the value of K is always equal to 1. Right? So this brings you your first equation, that force is the product of mass and acceleration. Here, mass will be measured always in kg, acceleration in meter per second square, force will be measured in Newton. Have you understood? If you want to write this equation in vector form, I would write, though you don't study vector form, but you should, I would write it as, is mass a vector quantity? No, mass is a scalar quantity. Acceleration is a vector quantity. Now, this is very interesting. Somebody might ask, acceleration is vector. Force brings acceleration. Acceleration is vector. You can get the magnitude from here, but my question is, in which direction is the acceleration? The direction of acceleration is always in the direction of force. Or you can also say, the force's direction will always be in the direction of acceleration. Just imagine, if I think that going on this side, the acceleration increases, then the force also should be on this side, right? And if you think that on this side, the acceleration reduces, right? Then the force, it will be negative. Then the force will be on opposite side. Acceleration reduces means negative acceleration. In order for negative acceleration to happen, force must act opposite to the body. So let's again ask ourselves, when we accelerate an engine, the engine is giving a more thrust to the particular vehicle. So the force is trying to increase the speed. The force is in this direction, the speed is also in this direction increasing, so the acceleration is in this direction. Let's say when a vehicle is braking means B-R-A-K-I-N-G, okay? When a vehicle is braking, what about its acceleration? Negative acceleration. Means acceleration is working opposite to the direction. If the body was going in this direction, acceleration is working in opposite direction. So force will be acting in this direction now, right? Force is opposite to acceleration. That's why acceleration becomes negative. ये चीज समझ में आया? But so the force, from here we need to now define. Now we need to say, can you define what is 1 Newton force? Somebody says, what is 1 Newton force. How do we define? In physics, your mind should always work in this way. What is 1 Newton force? 1 Newton force, when acting on a body of 1 kg, produces an acceleration of 1 meter per second square. 1 Newton force is defined as that force which, when acting on a body of 1 kg, produces an acceleration of 1 meter per second square. Now let's feel that. Let's feel that. How do you feel it? Let's say you have a body whose mass is 1 kg and you are subjecting it to a force of 1 Newton. Did you understand? At this time, say the body was at rest. Suppose this body was at rest, right? This body was at rest. The time is 0, 0, 0, 0. Then you expect that this 1 kg body means its initial velocity is 0. Its final velocity will be now 1 meter per second after a time interval of 1 second. 1 meter per second square means 1 meter per second square. And since this is continuously acting, right, in the next force acting means there cannot be uniform motion. There will always be acceleration. So when my time, this 1 kg body, when my time is 0, 0, 0, 2, I will expect its velocity now to be, this is V1, V2, 2 meter per second square. So if I see the gap here, this is a 1 meter per second over a time interval of 1 second. This is also 1 meter per second over a time of 1 second. Your heart will say, sir, ये तो uniform motion है. ठट, ये uniform motion नहीं है. Uniform acceleration है. Every second the speed is increasing. Oh, it's going like that. And that is happening because there's a continuous, this is 1. And if this body was in motion, say suppose this scenario was not there, it was in motion, then also his body's acceleration is changing with 1 meter per second every second. So what is 1 Newton force? 1 Newton force, when acting on a body of 1 kg, suppose his face is 1 kg and I give one slap of 1 Newton and his face can be separated, then his face will accelerate at a rate of how much? 1 meter per second every second. Clear? So based on this, we will get a lot of problems, but it doesn't end here. Let's try to see a little bit more deeper. Okay, some problems will come up over here, so we will be stopping for a lot of problems at this stage. But let's understand now one more concept, whether it is in your, earlier it is to be in syllabus. So the other concept is the concept of momentum. This is more important, momentum. So by now, what all we have learned, beta, in this chapter, the first formula we have got is force is mass into acceleration. 1 Newton is when 1 kg is accelerated with 1 meter per second square. This is what you have learned. And the previous formulas, V equal to U plus AT, S equal to UT plus half AT square, V square equal to U square plus 2S still holds on. Clear? Okay, fine. Now, momentum. Momentum is another physical quantity which actually defines quantity of motion. Very difficult for you to understand with this definition. Quantity of motion. ये क्या चीज हो गया? Quantity of motion. Quantity of motion. Now let me give you an example. A cricket ball, right, traveling at a speed of 10 meters per second is coming towards you. You are sitting and watching IPL match, and some Suryavanshi is batting. Continuous sixes are being hit. So you should be very careful in the stadium also. Sometimes some ball might come and hit you. So let's say the ball is actually coming at 10 meters per second. And the ball has a mass of, say, some blah blah, say 300 grams mass. And the ball is coming at a speed of 10 meters per second. And the ball comes and hits you. Injury will be there, no doubt. But imagine cricket was played with buffaloes. Bowler brings big buffaloes and he throws the buffalo, and the buffalo is being hit now, and buffalo is hit again with 10 meters per second, and the buffalo comes and hits you on the stand. In which case do you think more damage will happen to you? Buffalo. The more damage happens to you because the buffalo's quantity of motion is more. Buffalo's momentum is more. So can you, apart from the humor part, are you able to relate? What was the difference in the two cases? The mass. Momentum is something which will have both mass and velocity associated with it. Understood? So momentum is a vector quantity. Momentum is a vector quantity. And this vector quantity is represented by the letter P. As a vector, it will be shown like this, P. Momentum is the product of mass into velocity. Velocity is a vector. Momentum. Mass into acceleration is force. Momentum is mass into velocity, right? Momentum is a vector quantity. It defines quantity of motion, and it is the product. It is the product of mass and velocity. So again, you will ask, what is the direction of momentum? Can you define from this definition? The direction of the velocity is the direction of the momentum. Have you understood? This is a crucial thing, especially in games and all, where physical might is more important. Like say football. Football is a game of might, right? You will see two players in midfield are struggling for the ball. Both might have sprint at the same speed. Obviously, the one with more mass will be able to chitkow the other one. No questions asked. Head-on collision. You go and you bang some metro pillar. Do you expect the damage to happen in the metro pillar, or do you expect the damage to happen in your car? Obviously, your car gets a damage. But if you take Arjun tank from Indian Army and you go and bang that metro pillar, now where do you expect the damage to happen? Now what is changing? The mass is changing, and it will play a clear role. Sometimes a body might have very heavy mass, right? But have very less velocity. Let's say my mass is 100 kg, my velocity is 2. My momentum is how much? 200. And his mass is say 50 and his velocity is say 3. How much is his momentum? 150. 150. If both of us collide, he will have more damage because my quantity of motion is more. Come back to the carom board. The striker is always made heavier than the coins. Why? The striker is supposed to drive the coins, not the other way around. But when the striker goes and hits that rebound bar, at that time, the mass of the rebound bar is more. It drives the striker. Is it getting clear and all? So we'll see a lot of examples. This gets interesting from here. So momentum is a vector quantity given by the product of mass and velocity. Let's see what should be the SI unit of momentum. You can also find out mass is in kg, velocity is in meter per second. So kg meter per second is said to be the momentum. Okay. kg meter per second is said to be the SI unit of momentum. समझ में आया? kg यहाँ से आया, meter per second. बहुत कुछ सीखा आज आपने. Today you learnt about inertia, you learnt about Newton's second law, where you got the expression for force, then you learnt about a quantity called momentum. ठीक है? Okay. It comes that with the same velocity, as I said, if a bull was coming towards you, and with the same velocity, if a child is coming with a cycling and it's going to hit you, it's easy to stop the child, but not easy to stop that bull. Okay. How many of you have done this mischief of riding double in cycle? Double. Like in childhood we do. We make one more friend sit on our cycle and both of us. Braking will be much more difficult. As a single person, you apply, and if you drive two-wheelers, you will see with minimum braking, you are able to stop the car. Why? Because you are going at 5 or 10 kilometers per hour, it's only your mass. But you along with your boyfriend or girlfriend, same 10 kilometers per hour, at that time, if you apply the same amount of braking force, the two-wheeler will not stop. Because now the quantity of motion is more. Have you understood? Let's say some more examples. A bullet is very thin, but the bullet can actually penetrate inside few centimeters of concrete. So the bullet must carry a lot of momentum with it. So what are we jacking in the case of bullet? The velocity. Whereas if you see the rifle is very heavy and the recoil velocity is less. So if you want the momentum to be, generally we'll see momentum is conserved. Otherwise the rifle would have recoiled. If it is a thin rifle, it will just recoil on your face. Both sides the momentum will be same. How did the bullet get the momentum? The rifle only gave the momentum. The rifle will also experience the same thing, but in the opposite way. Those we will come in other class, in later topics. So is this understood? Now where does this play a role? You said force is equal to mass into acceleration, but the actual definition of force is not that. Actual definition of force is change in momentum. Rather, we will say rate of change in momentum is actually force. Rate of change in momentum. Rate of change of velocity. Second, square. So yes, kg into meter per second, there should be another second. Force is the rate of change of momentum. Have you understood? So whenever you say rate, what do you mean? You can write it like this. Change in momentum over the time that has elapsed. How did you define velocity? Velocity is the rate of change of displacement. Change in displacement over time. How did you define acceleration? Acceleration is the rate of change of velocity. Change in velocity over time. What was velocity? Rate of change of displacement. Now comes force. Force is rate of change of momentum. That means change in momentum over time. So how did we now let's put our notion F. How do you rate change in momentum? Any quantity's change is written as delta. So if P is momentum, then delta P is change in momentum over time. Is this clear? This is change in time, huh? This is delta T actually. T means change in momentum, say over change in time. Makes it better. Change in momentum or change in time. Now let's see. So force can be written as, what is change in momentum? Final momentum minus initial momentum. And I can write this as the final time, T final minus T initial. Is this clear? Is this clear? Okay, chalo fir. Let's define it further. Final time and initial time I am representing by T, where T is equal to T final minus T initial. Is this fine? It's a measure of time. Final momentum. Final momentum means what? Momentum is mass into velocity. There is nothing called final mass. Mass तो mass ही है ना? मिश्का को हम यहाँ से दौड़ा के वहां ले जाएंगे, मिश्का का मास थोड़ी कम हो जाएगा. So mass, but there is a big question there, huh? Mass into final velocity minus mass into initial velocity. This is change in momentum. Can I not take mass common? V minus u by t. तो समझ में आ रहा है? V minus u by t is a quantity which is known as acceleration. So you actually derived force is equal to mass into acceleration. How do you derive it? This is how you derive it. In order to derive that expression, the definition of force comes from the definition. Force is rate of change of momentum. So I'll keep on saying something. If you feel like you're right, and if you get goofed up, ask me again. Force is defined as the rate of change of momentum. Question arises, sir, what is momentum? A vector quantity which actually defines the quantity of motion associated with a body. What do you understand by quantity of motion? It is a quantity which is obtained by the product of mass and velocity. So it's a vector. What is its direction? Whatever is the direction of velocity. What is its SI unit? Kg meter per second. What is its significance? It tells me how to define that force. Force is the rate of change of momentum. Rate of change of momentum. That means change in momentum over time elapsed, or change in time. Change in time is nothing but time elapsed. So what is change in momentum? Final momentum minus initial momentum. What is momentum? Mass into velocity. So what is final momentum? Mass into final velocity. What is initial momentum? Mass into initial velocity. Mass taken common, v minus u upon t, which is a quantity we know as acceleration. So F equal to ma comes from here. Have you understood? Now, yeah. But will you be able to drink water in the manner in which you are supposed to drink? नीचे spill मत करना. झुक जाओ, झुक के देखो nozzle कहाँ पे है. Is this much understood? Clear? Okay. But this definition is actually not correct. Why it is not correct? Let us see. Means in grade 9, the way you study, you said, you did like this, see, force is equal to mv minus mu divided by t. Did you write this? You wrote this. My question is, who told you that the mass remains constant? है ना? Imagine, very ugly example, but this one you'll remember. Ryan running with an initial velocity to final velocity, in this process also parallelly addressing nature's call. Is his mass not reducing or changing? Yes na, yes na. तो आपको किसने ये राइट दिया कि आप मास को कांस्टेंट ले लोगे? You have been very very selfish. You're saying Ryan. Now I'll replace Ryan with a very nice thing which you all are aware of. Rocket. As the rocket is going up, don't you think the propulsion is going up? The fuel is being used, propellant is being consumed. So do you think the rocket at this height and the rocket at this height, there will be two different velocities? How do you say that the mass will be same? The mass will not be same, the mass will change. This is a version of force where you have been very very selfish. This version is valid only where there is no change in mass. Why you study this in grade 9? Because all questions you will study here is a truck with this much velocity attains a velocity of this much, collides with something. So you expect that the truck is not losing its mass, negligible, and in this question it will be written, assume negligible loss of mass. ट्रक का भी तो रेडिएटर फट के पानी गिर सकता है ना, छर्र करके. मास तो चेंज होता है. Everything's mass changes. Mass is not constant. Quantum mechanics talks in that way only. The mass is not constant. Mass also keeps changing, right? There is something called rest mass. When you study Einstein's laws and all, you understand what is something called rest mass. When you are at a velocity, your mass is not same as what you are. But let's not go that deep. In grade 9, we study this. Remember, we are studying this because this is with mass constant. If you go to grade 11, you will study it like this. Force is defined as, अभी आपको कुछ समझ में नहीं आएगा, the derivative of mass and velocity. Here mass is also variable, force is also variable. You know how grade 9 studies it? Grade 9 says, since mass is constant, take it out and you just differentiate the velocity. And this is known as acceleration. This is grade 9 approach. But with this formula, you cannot calculate rocket propulsion problems because in those, the mass is also changing. Like, understood? A balloon or a leaking football, or say a football which is leaking is allowed to roll, is losing mass continuously. उसमें आप इसके साथ ये नहीं कर सकते हो. There are very interesting problems. Robbery is going on continuously on a running train where sacks are offloaded. There the mass is changing. So in grade 12 when we go, we will bring one's mass out and we will only differentiate the velocity. Then once we will keep the velocity and differentiate the mass. In grade 9, this is taken as 0. There is no change of mass. But in grade 12 and 11, when you go and study higher mechanics, mass will also change and this will also change. So for our grade 9, what do we understand? Force is always rate of change of momentum. What is rate of change of momentum? Final momentum minus initial momentum over the change in time. This is nothing but mv minus mu divided by t. This is nothing but m into v minus u divided by t, which is me. At this juncture, you will find one more topic. Will not do maths today. Maths will do on our next day. So when you see force, what happened? Previous slide? Okay, yeah. Okay. Now there is one more interesting thing. वो उसको जान लेते हैं, फिर problem करेंगे. Can I change? Okay. If you see this expression and you multiply force with that short time, you get delta P. Change in momentum. Okay. Change in momentum and force on a short time. This quantity is known as impulse. Impulse is the product of force acting for a very short period of time. Acting for a very short period of time. Have you understood? Now, just imagine how is a karate player able to break so many tiles in one shot? If you ask him to break it in one go, he'll not be able to, means very slowly he'll not be able to break. But how does he break it? He is actually applying a lot of force, right? And he is applying it in a very short interval of time. So the change in momentum goes up very high. Give a tight slap on your face. When the impact is high, a very huge force applied for a very short period of time. The momentum, change in momentum will be more because the delta T is reducing. Are you understanding? Same thing happens in cricket and all. Why you have to actually say, for example, a cricket ball has been hit and it has been hit, or let's say, forget about a cricket ball being hit. Suppose there's a fast bowler who is bowling, batsman misses, it comes to the wicket keeper. The ball is traveling at what speed? 135, 140. 140's ball will be brought to rest. The wicket keeper will get a lot of pain if he just applies the force which brings 140 to 0 in short second. So what he will do, he will always take it along the direction of the ball. So he increases the time. He increases the time so that the impact of momentum is reduces. The force on his hands gets reduced. Because see, end of the day, ball is coming with a high speed. Ball will be brought to 0. This is the force which the wicketkeeper will feel on his hands. He wants less pain. So how to reduce the pain? By increasing the time. So how does a wicketkeeper take the catch? A goalkeeper takes it like this. In fact, if you are driving a car and you look at the reverse mirror and you see that somebody is tailgating you very close, means the kiss is unavoidable, and that behind person is driving in this manner. He's looking in this side and you have seen he's not looking at you. He will hit you. What should you do? Increase your speed so that the impact is minimized. Lagega to lagega hai, thoda kam lage. Now, imagine in the case of of all these karate players, what do? They will apply the force in a very short amount of time so that the momentum high. So anything that occurs on a shed, and typically for girls, as safety, one of the things which you should always know, in any human being, or more so with males, okay, say if this is your knee, if this is the knee and this is the foot, always remember this. This is called the femur. This is actually the weakest joint. Straight away hit here. Ye nikal jayega tak karke. But the person will not be able to get up from 1 minute. This is taught in self-defense. Straight away hit here. As strong with your leg, just hit this knee bone will just come out. Ye aur kabhi uth nahi payega. Anybody who is trying to, means as a self-defense, this is always tough. Ye aur uth nahi payega. और उठेगा भी तो कुछ नहीं का, because so much will be the pain that you can imagine. You are in this motion. What you are doing? You are again applying high force in a short interval of time. काम से मार दो. And anybody can kick with a kick, means push kick. बस इसको तोड़, you are safe. After that ये उठेगा ही नहीं. इसी को ही तोड़ना है, ठीक है? So क्या क्या सीखा आपने? You heard about impulse is not taught so much in grade 9. Earlier syllabus it used to be taught. Impulse is a force which acts on a body for a very short amount of time. Impulse. You hit a cover drive, you are always supposed to give a follow through. If the follow through is not given, but the ball has actually left your bat. The ball has actually left your hand. Are you understanding what I'm saying by follow through? You hit the ball and then you will move the bat like this. By that time, the ball has left your bat, but that short period of time is very much required. At the ball. ठीक है? अगले classes में our problems will be more on F equal to ma and with V equal to U plus AT and all those sort of things. So when you come to a class next time, please revise what is inertia, revise what is momentum, revise F is equal to ma, also revise F is equal to delta P by delta T. These formulas also you should know. And based on this, many questions. Later when we study Newton's third law, we will see that when you miss a catch, the pain is more. Actually, the pain is more. When you drop a catch. When you drop a catch. Why do, sometimes have you seen riots and all, when people do a lot of, what do you call, agitation? The rapid action force police will come with water cannons. Have you seen? Police will come with water cannons. to disperse the crowd, then you might be thinking, ah, it is so nice. The water cannon will be actually like a rain dance for us. Have you seen? Rapid action force they'll not fire first, they'll come with water cannons. Water cannon will give you that pain which you can't imagine. And we will see why that pain is more. And you'll actually see why a dropped catch is more painful. One, there is a psychological pain. I missed that catch. But physically, you will also feel more pain. ठीक है? रखें फिर आज इतना पढ़ के आइए. नेक्स्ट क्लास में हम न्यूमेरिकल्स करेंगे. ओके? चलिए.